Okay, here we are. Question 7. In a factory, an inspector checks a random sample of 30 mugs from a large batch and notes the number X which are defective. He then deals with the batch as follows. If X is less than 2, the batch is accepted. If X is greater than 2, it's rejected straight away. If X equals 2, he selects another random sample of only 15. If this sample contains one or more defective ones, then the batch is rejected. Right, it's given that 5% of the mugs are defective, so find the probability that the batch is rejected after just the first sample is checked. Well, what would that involve? The first sample is a binomial distribution. There are 30 mugs, and now slightly oddly we're going to take success as being finding a defective mug. Slightly twisted view on things. So the batch would be rejected if X is greater than 2. Now the probability of X being greater than 2 is 1 minus the probability of X being less than or equal to 2, and for this we can use the binomial tables. Unfortunately I haven't got mine with me, so I'm going to have to just put this into my calculator, and I'm getting 30 trials, P is 0.05, here we go, my calculator's saying 0.812, it would be 2 in the formula booklet from the tables, so there we are, 1 minus 0.8122 gives me 0.1878 or 0.188 to 3 significant figures. Cool. To show that the probability that the batch is rejected is 0.327, correct to 3 significant figures. Right. Well, hang on. This is it being rejected after just the first sample. It could also have been rejected if we did a second sample and that was rejected. We can't just do 1 minus the probability of it being greater than 2. You know, we can't do the complement of that, because of course there's also the option if X equals 2 it could be rejected or accepted. Right then, so we need to look at that. So if X is bigger than 2, we've got a probability of 0.1878. Then it would definitely be rejected. If X equals 2, that is, we're looking for the probability of X being equal to 2, and that would be, well, we could do either way, can we? 30C2, 0.05 to the 2, 0.95 to the 28. That gives us, where was it? 30C2 times 0.05 squared times 0.95 to the 28 gives us 0.2586 as that probability. Alright, then if that happens we need to find the sample containing 1 or more defective mugs. It would be rejected. So we've now got a new distribution where there are 15, binomial, there are 15 in our sample, and we've got the same probability of success, and we want to know the probability that Y is greater than or equal to 1, at least 1 has to be done. That is 1 minus the probability of Y being 0, which is 1 minus, well, 0 would be 0.95 to the power of 15. So that's 1 minus 0.95 to the power of 15 gives us 0.5367. Okay, so rejected. Here we've got 0.1878, our probability from the first part, plus 0.2586 times 0.5367. We're multiplying these because it has to be that we go to a second inspection and that inspection finds a dud. And that, if we work it all out, gives us 0.5367. an answer of 0.3266 I've got. So 0.32, what would it be? Hang on, that would be 0.327 to three significant figures. Which is the answer that was given, of course, isn't it? There we go, 0.327. Haha! Batches are checked one after another. Find the probability that the first batch to be rejected is either the fourth or fifth batch that is checked. Right. Hang on then. So, what we're doing now is we've turned this into a geometric distribution, haven't we? We're saying that we're going to keep on checking batches until we've rejected one. Now the probability that a batch is rejected is 0.327. That's what we found earlier. Let's just store that. Oh, what do I do there? There we are, store that. So, fourth batch. Well, in order for the first batch to be the fourth, we would need to have had 3 batches that have passed fine, and then the fourth one to be a problem, and the fifth batch we would need to have had 4 batches that passed fine and the fifth one being our problem, and we need to add these two things together, so that is 1, what have we got? 1 minus of a cubed times that answer plus 1 minus that answer to the 4 times that probability that we were using, and this has given me an answer of 0.167 to three significant figures. There we go. And that's maths.